Right, let's finish this paper. Question 11. The volume of Venus is 9.3 times 10 to the power 11. This is 85% of Earth. What's the volume of Earth? Right, okay, so what we've been told is 85% is 9.3 times 10 to the power 11. What we're asked to find is what the full value, the full 100% is. There's a couple of different ways you can do this, okay? So if you wouldn't have done it like this, then do it your own way, just double check the answer. What I'm going to do is I'm going to find out what 1% is. If I know that this is 85%, this represents 85%. If I divide that by 85, that will tell me what 1% is. Okay? This value, I'm just going to write it down, it's approximately, that's what it is on the calculator. Now, if that's 1%, how do I get 100%? Well, I times this number by 100, and that, oops. You times this number by 100, and that will give me 100%. 1.09 times 10 to the power 12. Oops, I'm going to write it on the line below. 1.09 times 10 to the power 12. It doesn't mention anything about rounding, so just be careful, okay? If it said one significant figure or something, you just need to make sure you double check. Number 12. Here is part of a circle. The radius is 13. A to B is 20. Find the width. Right, I'm hoping you're thinking of the correct topic. Right, this is one of these ones that comes up every single year. This is a Pythagoras question. If the length or the distance between the centre of the circle and the edge is not given like that, put it in. Right, there's your triangle there. I'm just going to draw it out separately. Right, what values do we know? We know this one down the side is 10 because any time you draw that like that, it always halves that chord, so it's half the 20. This has created a right-angled triangle. The bit across the bottom is the bit we're trying to find. I'm going to call that one x. However, to do Pythagoras, we need to know two sides. This one here, that's just the radius. And we were given, why did I write that? We were given the radius in the question. The radius was 13, so that's 13. Okay, so now we're going to use Pythagoras. How do we find x squared? Well, we do 13 squared, 10 squared. What do we do with them? Add or subtract? We're working out a smaller side, so we do a subtraction. Okay, remember this is a calculator paper. Okay, but remember x is not 69. How do we find x? We do the square root. Which gives us about 8.3. The number after the 3 is a 0, so I'm quite happy to leave it as 8.3. This is not our final answer though. The part that we've just worked out is this part here. The question was find the width. So the width is this bit as well as the length of x, which was just worked out. That bit there that I've put in the diagram in red, that is just the radius. So the total width altogether is the 8.3, which was the x value. Add on the radius, and the radius is 13. And is it metres? Nope, centimetres. Always put your units in, please. Okay. Number 13. Right, angles, sides, looks like Pythagoras. Just ignore me. It looks like a trig question, a sine or a cosine rule question. Let me see, this should hopefully be the sine. Yep, here we go. I will put it up here. Or maybe I'll put it at the bottom. Yeah, that's maybe better. There you go. Right, okay, let's see the values, what we need to work out. Right, so we've got all these values. First of all, double check that the measurements and the angles that you've been given are actually on the diagram, okay? Sometimes they're not. These values have all been put in the diagram, so that's fine. What is the bearing of the yacht from the trawler? Let's see. the bearing of the yacht from T, the bearing from T, so start from T clockwise, going all the way round to the yacht. See that angle there that I put in black, that if I was to guess might be something like 300 or something, that's the angle we have to work out, okay? Now trigonometry deals with angles inside triangles. Trigonometry is not going to work out that angle for us. However, trigonometry is going to work out this one, the wee one in the middle. That wee one in there. Try to call it X, okay? So it's the one inside the triangle. That's what we're going to work out. Now, do we have an angle across from a side inside that triangle? No, we don't know any angles at all inside that triangle. Nothing, okay? So, what we're going to have to use to work out that angle is this formula here. The cosine formula, okay? So the cosine formula, this one, works out an angle when you know all three sides, which is what we actually have here, okay? So one of the sides has to be called side A. See this one here at the end? Side A, because you're subtracting it. This one has to be a particular one. The one that is represented by side A is this one here, because it's the one that's opposite angle A, or angle X, okay? So the other two doesn't really matter. We'll say 10.2 squared, oh no, it's 10.3 squared. I should write a wee bit bigger. Plus the 5.6 squared, take away the 7.2 squared. And this is all to be divided by 2 times 10.3 times 5.6. Now what I suggest when you're doing a question like this is, key in the top line, top line gives me 85.61. Bottom line is 115.36. And now do the division, which is, on my calculator, approximately 0.742. Okay, now remember we're working out an angle here. This angle is not going to be 0.7, let's just double check. It's not going to be 0.742 degrees. To find the angle, we do, remember, cos of angle A. We do inverse cos. Okay, shift cos, inverse cos, second function cos. On the calculator, it's approximately 42 degrees. We'll say 42.1 since it's 0.08. So I'll say 42.1. That's angle X that we've just worked out. Remember at the very beginning I said the angle that we're asked to find out is the full angle all the way round, clockwise, right round to the 5.6 line. That's 5.6. The wee red bit is 42.1. So that means the bearing is actually, it's the 240 plus the 42.1. So approximately 282 or 282.1. They're not worrying about rounding much, okay? 282 is absolutely fine. Right, next one. Straight line has this equation. What's the coordinates of the point where it crosses the y-axis? Okay, to find where it crosses the y-axis, what do? You sub in something. Because it says where does it cross the y-axis, you sub in x0. Okay, if it had said where does it cross the x-axis, you sub in y equals 0. So we sub in x0. So 2 zeros, take away 5y equals 20. 2 zeros, 2 nothings are nothing. So this is, we've got what? Basically we've got negative 5y is equal to 20. How do you find y? You do 20 divided by negative 5. 20 divided by 5 is 4. 20 divided by negative 5 is negative 4. So the question was, what's the coordinates? Put your x value, then the y value. What was x? It was 0. What's y? It's negative 4. So that's our answer. Number 15, express this as a single fraction in its simplest form. Right, okay. This is a division. So the method for division, you should be thinking the method for division is you flip the second and turn it into a multiplication. That's the method for division. Okay. However, before we go any further, we're looking to simplify as well. If they ask us to simplify an algebraic fraction, look to factorise. Okay. Now there's not much we can do about these, but look at the bottom of the first fraction. Factorise. Is there a common factor? Nope. But we can do something else with it. It's actually a difference of 2 squares. Okay? N squared, n times n, 2 squared, 2 times 2. So now we can simplify. Remember, when you're doing algebraic fractions, if there's anything you can cancel out that's identical at the top, identical at the bottom, they can cancel. There's an n minus 2 and there's an n minus 2 as well. So what we'll end up with is n at the top only. At the bottom we've got a number 3 and an n plus 2. Put my 3 at the front, n plus 2. You don't need to multiply out that bracket, that's perfectly fine like that. Okay? At number 16, oh, the umbrella one. Right, okay, the measurements are on the diagram, just double check, read through it, make sure that all the measurements are on the picture. The umbrella is 85. Basically, can the umbrella fit in the locker? Now, the longest position you can get in that locker, right, if you were to put something in that locker, the longest distance would be from the bottom corner at the front to the top corner at the back. It's basically a space diagonal, that's what you call that. It would go right through the middle there. Okay, so what we need to do is find out the length of that distance, that space diagonal. Once we find the length of that, we can compare it with the 85 and decide if it fits or not. Okay, now let me just wipe this off. Right, how do we find out a diagonal length across the middle? We've got lengths, triangle, there's squares. This is a Pythagoras question, just in case you haven't quite noticed that yet. Right, see if I can draw it in. Right. There's a triangle that I'm going to use, hopefully, to do Pythagoras with, to find out this length here, x. Now, looking at that picture there, I can't do Pythagoras in that at the moment, because I know the 70 down the side, but I don't know that bit across the bottom. Okay, I'm going to have to work out that one first. Right, so on the bottom, I know it's kind of drawn a bit like that, but it is actually a square, okay, that measures 40 by 40, it tells you that in the measurements, and it's that distance there. Okay, so really it's just a triangle. I'm going to wipe a bit of it off. Right, so I'm going to not call it x, I'm going to call this one y. So I'm doing Pythagoras on the bottom square of this diagram. Okay, then I can find out this one here and basically use Pythagoras to find x. So how do I find y squared? Well, I would do 40 squared plus 40 squared. Okay, remember it's a calculator question. Take the square root, 3,200, take the square root, remember, because it's a Pythagoras. Take the square root, gives me about 56.5. We'll say 56.57, we'll say, approximately. Okay, remember this is not a final answer, so try not cut many numbers off it. You can leave it as the square root of 3,200, that's absolutely fine. Right, so now going back to our original question. This distance across the bottom, we've just worked it out, 56.57. The distance up the side is 70, and we're trying to work out this. So that was the first thing we've done. Right, I'm just putting it step 1 and 2, just so that when I take a screenshot, if you look back, you can see what we've done first, okay? Right, so how do we find x squared? Well, we do 70 squared, add on the 56.57 squared. Okay, I'm going to just do these quickly. When you square them both and add them up, you get 8,100. So remember, to get x, you take the square root. You might be able to guess the square root. You know the square root of 81. The square root of that is 90. Okay, so that means that diagonal distance, the space diagonal it's called, going right through the middle of that cuboid, is 90. That's the maximum distance it can take. It says the umbrella's only 85, so can it fit? Yes, it can fit. It fits because 85 is less than 90. Okay. Is basically anything less than 90 would be fine. Okay. Right, number 17. Sector of a circle inside a triangle. We're given some of the measurements. Just make sure you read. Not all the measurements are on that diagram. Right, this is very important. You're looking at these numbers here. What is the area of the shaded part? Right, it's a triangle with a semicircle cut out. So basically you're going to work out the area of the triangle, work out the area of the sector part and do a subtraction. Okay? So, area of the triangle. You've got an area of a triangle formula. The area of a triangle is a half AB sine C from your formula list. A and B are the two sides of the triangle. What are the two sides of a triangle? It actually tells you. O to B is 38, it tells you down here, and O to C is 55. So it's a half times 38 times 55 times sine of the angle in the middle, sine 75. That's a 75. Key into your calculator, 1 divided by 2 or 0.5, half times 38 times 55 times sine 75. About 993.85. Okay, that's the area of the triangle. Now we need to work out the area of the sector. The area of the sector is the angle over 360 times by area pi r squared. So it's 75 over 360 times pi times the radius. We're told it is 30 squared. Key it in the calculator. I get 589.05. I'll put it to 2 decimal places since I've done that with the last one. Okay. And now what we've worked out is we've got the area of we've got the area of the sector and we've got the area of the triangle. So to get the shaded area, what do you do now? Shaded area is basically the triangle, take away the sector. 993.85, take away the 589.05. Do the subtraction. Gives you about let me just go back and key something in. I'm just going to key that first calculation in. Again, a half times 38 times 55 times sine 75 is 1009. Yeah, I don't know what happened there. See that wee number? It wasn't quite right. That was 1009.39. Don't know, I think I maybe put in sine 74 or sine 70. I'm not sure what happened. So do the subtraction. Gives you approximately 420. Does it mention anything about rounding? It doesn't mention anything about rounding. The one after the 0 is a 3, so 420 is absolutely fine. Area, squared centimetres, squared metres, is squared centimetres. Okay. Number 18. Right, the carton is 16, it has a volume of 576. There's a couple of different ways you can do this question. So the question says, show that they are not similar. If they're similar, they would have the same scale factor. Okay, there's a couple of different ways you can do this. I'm going to show you the most common way that people do it. Okay. Right. I'm going to show you the most common way that people actually attempt this question. So, you're told the wee volume is 576. Now, the scale factor. If you're working out the big volume, what you would actually do is you'd work out a scale factor of, we're working out the big volume, you do 24 divided by 16, which is 1.5. Now if you're working out the big volume, remember what you do when you're doing a volume scale factor, you take the scale factor and you cube it, and then times it by the wee volume. If it was an area you were working out, you'd take the scale factor and you square it. Let's see, cube it and times it by 576, which gives you 1944. So if they were similar shapes, that would be the area of the big one, or the volume of the big one rather. So they're not similar, because it's obviously not the correct volume. It says the volume of the big one is actually 1125. So they're not similar volumes, they're not similar shapes, because 1944 is not 1125. That is the most common way that people would tend to do this one. Okay. I think there's a part B. The large carton is redesigned so that they are now similar. The volume of the redesigned one is 1500. What is the depth of it? Right, let's have a wee look. Part B. Right, let's see. So go back to the first one. So the height of the first one is 16, the height of the second. Alright, so we're working out the height of the second one. Okay, that's what we're trying to find. We've got the volumes. We know that the volumes, we know the scale factor's cubed, right, okay. So we don't know the volume of, we know, right, I'm going to have to draw a wee picture out here. Right, so this one's 16, but we don't know that height. That's what it is. The volume of the big one is 1500, and the volume of the wee one is still 576. Right, that's us now. That makes sense. Okay, so we have to find the height of the big one. That's basically what we're trying to do here. Right, if we knew the scale factor, we'd be able to do this. Okay, we know the volume scale factor though. So the volume scale factor is 1500 divided by 576. That tells us 2.604, roughly something like that, okay? Basically what that tells us is the big volume is 2.6 times bigger than the wee volume. That's what this is telling us, okay? However, remember, if you're at work, we don't simply take 16 and multiply it by 2.6 to get the height of the big one. That's not how this works, okay? This is a volume scale factor. To actually get the normal scale factor, think of what we've done with the scale factor in the first one. We took the scale factor and then we cubed it. We're working backwards. We're trying to work out the normal linear, we call it the linear scale factor. To find the linear scale factor, you don't cube this, we do the reverse of it. We do what we call the cube root of it. Okay, the cube root, you should have a wee button on your calculator that works out the cube root, which gives me, I don't know what I typed in there, it's definitely wrong. Right, let me start again. 1500 divided by 576. And I want to do the cube root of that answer. 1.375. 1.3758. So what this is how many times bigger in height the wee one is, the big one is compared to the wee one. So the tall height or the depth is simply 1.3758 times by 16, which is approximately 22 centimetres, roughly about 22. Okay, I know this one was quite tricky. When it was done in the exam, most people found it very, very difficult. It was a challenging question. Okay, I'm going to set you questions like it, have a go, and come back to me if you need help.